are you?
Good.
Are you ready to talk about Z-scores and dogs and a cat
Oh my gosh, yes, I'm so ready. I love cats and dogs.
and Z-scores?
And Z-scores, of course, Z-scores too.
Yes. I want to get a dog and name it Z-score.
Oh my God, that'd be so cute.
Look at how sad Dexter's life is right now, though.
Oh, poor Dexter.
He's going through it right now, but he's gonna be better. Dexter,
Yeah, he
can you
is.
just take a nap while mommy works? It'll be deconed in like a week and a half. Okay. So first of all, what is a Z-score?
Well, a Z-score is the number of standard deviations away from the mean that the data value lives.
Right. So it's like this unit of measurement that tells us like how far away from the mean something is with direction.
Yeah.
If a Z-score is positive, what does that mean?
Yeah, but Z-score is positive, that means that it lives above the mean.
Perfect. And then if it's below the mean, it's going to be what? Positive, negative?
Negative
Yeah.
score. Yeah.
Perfect. Okay, then why don't we go ahead and do one?
Okay.
And I'm going to share our little worksheet. So we'll notice that and by the way, before we get started, we should probably discuss that Luna is your baby.
Yes, we definitely should.
How old is Luna?
She's 3.
Here's Dexter. He's my baby.
Oh,
he's 11. Stella is like less than a year. She's my friend's cat.
Okay, she's young.
Oh my gosh, where did Molly go? Oh, here we go. This one. Here's Demi. She's your other baby.
That's my other baby, my red-nosed pit.
Is it Demi or Demi?
Demi.
Okay.
Like Demi Moore, like Demi Lovato. Demi Lovato is my inspiration for her name.
Well, yeah, but I say Demi Lovato, but I say Demi Moore.
Oh, you do?
Yes, I don't know why.
That's so funny. Same spelling. Tomato.
Yeah, Demi Moore, Demi Lovato. Okay, so Demi, so she's like, she like lets it go.
Yeah, she does. She does. Lets it go all the time.
Okay, and then this is Molly. I like to call her Girl Dexter because that's Dexter's sister.
Oh my God, how cute.
Yeah. Okay, so let's focus though.
Okay.
Now, this doesn't ask us, like none of these first few problems actually even say like what is a Z-score, but they ask us to find something and the result that we find is called a Z-score. Want to read me this first one?
Yeah, okay. So the weight of an adult Staffordshire Pit Bull Terriers are normally distributed with a mean of 60 pounds and a standard deviation of 3.2 pounds. Stafford Pit Bull Terrier Luna weighs 65 pounds. How many standard deviations away from the mean is Luna's weight? Illustrate graphically.
Okay, cool. So we're how many standard deviations away, and we'll also be told with direction. And I just took a couple notes while you were reading.
Awesome.
We've seen already that we call the mean U of a population. We call the standard deviation sigma of a population because we're talking about all of these types of pits.
Right.
And then let's use X to represent. We can call it X of L for Luna if we want.
Yes.
And her weight is what again?
65 pounds.
Cool. 65. So you can't like pick her up, huh?
Yeah, it's pretty hard to pick her up. I could pick her up from like half of her body just to give her a kiss, and then I put her back down.
Oh, well, that's what's important.
Exactly.
Okay, let's get a picture going. I'm going to just put our mean of 60 down the center. So far, so good. So there's our mean. And then let's put in the standard deviation of, let's go, 3.2 is here. And this is something we're going to draw frequently. Sometimes we'll have a curve above it. Now this one tells us it's normal. So like as we get to higher level stuff, we'll care about that. Right now, we're just going to focus on this number line.
Okay.
So what would we have here? We'd have 63.2. Yeah. Help me, Brittany. Math is hard.
66.4.
Okay.
And then if we go the other way, 56.8.
Okay. Okay.
That should be good.
Yeah, we could keep going, but why, like, how did you know that we could stop drawing?
I knew because when we read the problem, Luna weighs 65 pounds. Mm-hmm. So I know that when I'm looking at the number line, I'm going to be looking on the right side of the number line, so I didn't need to go further with the left.
Perfect. Okay, so now Luna's weight is like somewhere between 1 and 2 standard deviations to the right. So I don't know if it's like perfectly halfway, but it's somewhere in there.
Right.
So that's Luna's weight. And what we could do is now say how many standard deviations away from the mean is that. So the first step is to figure out how many units away from the mean that is. So if we're graphing x equals the number of pounds, the weight of a dog, Luna's difference in weight from the mean to hers, like what is that difference? Like if we take Luna's weight and we go minus the mean weight, how many more pounds does Luna weigh?
5 more pounds.
Right, so as far as pounds go, she's 5 pounds above average.
Right.
All right, but sometimes we're interested in not the units of the problem, but in standard deviations. So basically the next question is how many standard deviations goes into that 5 units? And like in our picture, we can see that it's gonna be 1 and some change, right?
Mm-hmm. Right.
How do we figure out how many times 3.2 goes into that 5?
Well, we can divide it by the 3.2.
Yeah, exactly. We're saying goes into it this many times. That's exactly like when you were in like grade school and division was saying like, how many times does 2 go into 6?
Right.
Yeah. And so then we can get a value out for this. And do you have your calculator BFF handy to have a value for us there?
Always.
What you got?
Okay, so I got that it's approximately 1.5625.
Cool. And often we do just kind of round z-scores to like 2 decimals. So if you want to call it 1.56, that's fine. So that means that Luna's weight is 1.56 standard deviations above the mean, right?
Right.
And what we actually call that is the z-score for Luna.
Yes.
And so if x sub L is 65, every x value has its own corresponding z-score, which counts the number of standard deviations away from the mean it is. And so these are like besties.
They are.
Awesome. And so we actually kind of came up with a formula there. Anytime you want to find a z-score, like we took Luna's weight x, and what did we subtract from it?
The mean.
Yeah, and that told us how many units away from the mean her weight was. And then we divided by what?
The standard deviation.
Yeah, so this actually is always going to work for how to find a z-score. Cool. I like to put it in words because it's not always those symbols. Like sometimes it's like mu sub x. So I will literally sometimes just write data value. So that's like Luna's weight minus the mean over the standard deviation. Do you think we're ready for another one?
Yeah.
Okay, you take the lead. I'm just going to write what you tell me to on this one.
Okay, awesome. Adult Jack Russell Terrier weights are normally distributed with a mean weight of 16 pounds and a standard deviation of 2.7 pounds. Jack Russell Terrier Dexter weighs 14.2 pounds. How many standard deviations away from the mean is Dexter's weight? Illustrate graphically. Oh my gosh, Dexter is like perfect to pick up, 14.2 pounds.
Yeah, which is good because he's an old man now and I have to pick him up anytime we go up the stairs.
He's so cute. Okay, so then I'd say for this one, first we want to know what we're working with. So we can note that our mean is going to be 16.
Great.
Our standard deviation is going to be 2.7.
Got it.
And our x equals 14.2.
Yeah, data value is kind of what I call x. So I'm with you, 14.2.
Perfect. And then now we can draw a number line so we can kind of get a visual going of what we're looking at.
Okay.
And then in the middle, we can put our 16 because that's our mean.
Okay.
And then our standard deviations is 2.7, so we could start counting to the right and to the left of the number line.
All right.
So if we go to the right, it's going to be 18.7. And we can actually go back down because Dexter's weight is on the left side of 16 pounds. So we're going to do 13.3.
Cool.
And then maybe one more. Let's do like 10.6.
Okay.
And that should account for what we need to find for Dexter, because his weight's going to be somewhere between the 13.3 and the 16.
Yeah, so he's in here somewhere. I'll call that X. What do we call that? X sub D for Dexter is 14.2 pounds.
Perfect.
Cool. Now what?
Now we can just plug in. We can actually use our formula here if we want.
Okay.
So we could do Z equals, and we could plug in for X. So we could do 14.2.
Dex is 14.2 pounds.
Minus our mean, which is going to be 16.
And notice, before we go too far on that one, notice that that's going to come out to be negative this time, huh?
Yeah, it is.
Why?
Because Dexter's weight is below the mean, so it's going to be a negative number.
Perfect.
Yeah. And then I'll divide it by our standard deviation, which is 2.7.
Cool. And then, do you know what that comes to?
Yes, I do. So that comes approximately to negative 0.6667.
Oh my gosh, he's the devil dog.
Oh my God.
Okay, wait, let's just throw another 6 in there because it does keep going. I just don't want him to look like, he's evil.
Yeah, no, he's not evil.
It's 0.6 repeating in the negative. So it's like a little more than halfway to the left of the mean, right?
Right.
Okay, so Dexter's Z-score, Z sub D, is negative 0.6666. So a little thing to notice is even though his weight was below the mean, we still start with whatever the data value is in the subtraction, and then we take away the mean. That way, any negatives will arise naturally, right? We don't have to try to think about that.
Yeah, that's what I like about plugging it in.
I know, you gotta love a formula, right?
Right, it's nice.
I know. Let's talk about Stella. She's so cute. This is my friend's cat.
She's so cute.
I have to show you before and after pictures of her because he found her as a newborn kitten on the side of the road like 8 months ago, and then he nursed her to health. I'll show you before and after. I'll put them in this video for everyone because oh my gosh, he like saved this kitten, and then I kept going, "Are you gonna keep her?" And he's like, "No, I like dogs." No. And then eventually I was like, "So she's yours, right?" And he's like, "Yeah."
Oh, she's so cute. She's like a calico cat.
I know. Okay. Let's see if we can go a little faster. Help me out with this one.
Okay, awesome. So the mean weight of a 1-year-old domestic house cat is 4.5 pounds with the standard deviation of 1.1 pounds. Stella is an 8-month-old house cat that weighs 4 pounds. How many standard deviations away from the mean is Stella's weight? Illustrate graphically. So we can kind of like throw out what we did before. So our mean is going to be the 4.5. Our standard deviation is going to be 1.1. And our X, which is Stella's data value, is going to be 4. Nice. And now we can kind of draw that number line. So you're going to illustrate graphically.
Okay.
And we can place our mean at the 4.5.
And I draw it in the middle. It doesn't actually need to be in the middle. Like it's just visually what I like to do. When we get to the point about like the shape of a distribution, then it does matter if that's in the middle or not. Right now, it's just something I like to do.
True. Looks nice.
Pretty.
Okay, then we can count now with our 1.1 standard deviations to the left and to the right.
Okay.
So to the right is going to be 5.6.
Okay.
And then to the left is going to be 3.4. And then Stella's weight's going to lie in between that 3.4 and 4.5 because she's 4 pounds. Like somewhere in there.
She'll be in here somewhere.
Yeah.
So is her Z-score, her number of standard deviations, is it going to be positive or negative?
Hers is going to be also a negative.
Yeah.
Yeah.
Okay, let's get Z. Now above that was Z sub Dexter. Let's call this Z sub Stella.
Perfect. So we're going to do our 4 minus 4.5.
And that's how many pounds away from the mean weight she is, which is negative half a pound. So half a pound below.
Yeah.
Okay.
And we're going to divide that by 1.1.
Okay. And do you know how many times 1.1 goes into 0.5?
Yeah. Approximately negative 0.4545.
Cool. So she's below the mean as well, but she's not as dramatically far below as Dexter, right? Like they're both below the mean, but he's a little further left
Right.
than the mean. Yeah.
Yeah.
Okay. That's gonna help us with the next question, isn't it?
Mhm.
Yeah. So why do
Yeah,
we
it is.
yeah, why do we find Z-scores? Well, like one thing that it really helps us do is compare like apples and oranges or Dexter's and Stella's because
Yes.
maybe these we're comparing two things that don't have the same mean, don't have the same standard deviation, but we want to know which one is varying from average in its category by like more dramatic than the other one is. I don't know if that makes any sense.
Right. No, yeah, it does.
I like the pictures for this. So like I'm gonna get rid of some of the congestion in here. Actually, let me leave Dexter's weight in there. Let me just grab a couple of these pictures to put for the, because I just know what's coming on the next problem. So I'm gonna do this.
Okay.
Let me just note that this will be X sub D right here, right? That's
Yeah.
Dexter's
For
weight.
Dexter.
Yeah, and we know that Z sub D was about negative 0.666667.
Yeah.
And then let's do Stella's picture. I'll modify that a little bit too. And I'm
Okay.
gonna just line up those means kind of close together and maybe make this, so I wanna make it look like the means line up
Right.
and the standard deviation. Do you know what I mean?
Mhm.
Even though the means aren't the same, they line up similarly, like visually.
Yeah, they do.
Okay, so then let's put Stella, this will be X sub S, and Z sub S was about negative 0.4545-ish. Okay, why did we do all that? Talk to me, what's up with this one?
Well, we want to see like who weighs less relative to their species, their breed, their age. So,
Yeah. Okay,
yeah.
first question. This question's easy. Who weighs less as a creature in the world?
Cats, Stella.
Yeah, Stella weighs less. She's 4 pounds. She's a baby angel.
Yeah, she is.
Dexter weighs more. He's like over 10 pounds more than her. He's the heavier creature, right?
Mhm. Right.
But relative to everyone else in their category, who is straying from that center, that mean, by more? That's what this is asking.
Right. Yeah,
So,
so if we're looking in that way, then Dexter is straying a little bit more from the average.
yeah, see how Dexter's weight is further left of the mean than Stella's weight is?
Right.
Right. So even though Dexter is the heavier animal, he weighs less relative to other Jack Russells than Stella does relative to other house cats.
Yeah.
Okay, so how could we write this?
Okay, so maybe we could start with noting Dexter's weight. So like Dexter's weight is approximately 0.667 standard deviations below the mean.
Okay, so Dexter's weight is 0.66667 standard. I have to write it out.
Perfect.
Deviations below the mean. That's what the Z-score tells us. Now,
Mhm.
before we go further though, I'm going to notice you didn't say negative 0.66667 standard deviations below. How come we didn't need to put a negative there?
Yeah, so we don't use the negative because we're already saying that Dexter's weight is below the mean.
Right. So when we say that his Z-score is negative, that's just telling us the direction of his score. So when we write it out, we don't necessarily need to write that negative, right?
Right.
Depends how
Yeah.
we're phrasing it. If I wrote Dexter's weight is blank standard deviations away from the mean, then I'm not telling my reader if it's above or below, so I need to put the positive or negative. But when you put the word
Yeah.
below, you're indicating that it's a negative Z-score. Okay, sorry, I had to interrupt because I get excited. Tell me more.
Okay, and then we can talk about Stella too. So Stella's weight is approximately 0.4545 standard deviations below the mean.
Okay.
So then Dexter's weight is less relative to his category of dogs, Jack Russell Terriers. his breed.
Yeah, so below the mean. And that's below the mean for cats and below the mean for dogs, like respectively.
Right.
So Dexter strays further below the mean,
Mm-hmm.
below average for his class.
Right.
So the answer is Dexter weighs
Yes.
less relative to his class, not less on the earth.
Yeah.
Awesome.
His class.
Okay, well, so far we're nailing it, but here's where it can start to get a little harder, is when people start to get like really in the swing of doing problems like the first three we did, where they're all kind of the same.
Mm-hmm.
And then we mix up what information is given. Like,
right.
And I know you like this formula, so whatever people need to do, if you need to tattoo it on your wrist, whatever, anytime you have like an algebraic formula, if you give me all but one variable, I can find the missing variable, right?
Yeah.
So far, the missing variable has been Z. We've been finding that each time.
Right.
But sometimes we know Z, and we need to find something like X.
Yeah.
But honestly, if you give me any three of those variables, I can find the fourth one for you.
Mm-hmm.
So we did some good practices noting what we were given each time with some color coding, but you want to go slow and be real careful about what you're getting.
Yeah,
so
that's true.
Want to help me out with the next one?
I would love to. My demi girl.
Yes.
There she is. My
Baby
sweetheart.
Angel.
She's so cute. Baby Angel. She's 7 years old.
Oh, so cute.
Okay, so the weight of adult red-nosed American Pit Bull Terriers are normally distributed with the mean of 45 pounds and a standard deviation of 3.2 pounds. Red-nosed American Pit Bull Terrier Demi has a Z-score of Z is 12.5. Big girl. Yes, she is a big girl. How much does Demi weigh?
Okay, so we're given 3 pieces of info again, just like we were on the other side of this worksheet.
Right.
But they're not the same 3, are they?
No. This time we were given her Z-score, so we actually got Z for this one.
Right, and what are we looking for?
So we're going to be looking for X, like how much Demi weighs, that data value.
Yeah, what is Demi's weight? That's what we want to find.
Mm-hmm.
And then I think you know a formula to help us with this.
I do.
What is it?
The formula is going to be the same formula we used before. So Z equals X minus the mean over standard deviation.
Nice. And then we just sub in what we know.
Yeah.
Exactly. Okay, tell me what we know.
Okay, cool. So we know the mean is 45.
Okay.
And we know, and we know our standard deviation is 3.2.
Okay.
And we're giving our Z-score, so we know that is 12.5.
Right. This time we're given this bad boy over here. 12.5. Picture her. She's really over there on the right.
Yeah, she is.
Honestly, that's how I feel after COVID. Like, I feel like I'm way over on the right as well. I need to lose my Rona rolls.
I think we all need to lose those.
Okay, and then we're looking for the X, so that's still our unknown.
Yeah, exactly.
Look at my creepy 5.
That is a pretty creepy 5. I was going to mention that, but...
I'm surprised you didn't because I give you such a hard time about your creepy normal curves.
Yeah, you do.
They're really bad.
They're really bad. I've been trying.
Yeah, step it up. Okay.
Now, step it up.
Do you know algebra? Do you remember algebra? Are you aware of algebra, Brittany?
I'm aware of algebra, yes.
How do we solve for X?
Okay, we're going to solve for X. We're going to have to like move around some pieces for this.
Yes.
So we can first multiply.
Okay, cool.
Okay, so you can multiply the 12.5 or the 3.2 to each side.
3.2.
Algebra is my really strong suit.
Wait, it is or it isn't?
Well, it used to not be. I mean, I'm okay now.
Well, okay, so that's great. It's okay if you're not as well because it's like, you know what? We kind of just, as we go, pick up little new things. And here, if we're trying to solve for X, we're trying to isolate it. So we have to work our way into X by undoing what's being done to X.
Right.
So if x is being like divided by 3.2, and a division symbol like that is a grouping symbol, meaning what happens on top is first. So if we're dividing by 3.2, that means we need to multiply to clear that fraction.
Right.
So that was just kind of like the long way home on why we did that.
Yeah.
You happen to know what that comes out to?
Yes, 40.
Okay, beautiful. That's a perfect 40. I love it.
Yeah,
And
it is.
then we still have x minus 45 over on the right-hand side.
Yes.
Solving for x, last move.
So
And,
plus 45 to both sides.
and that means
85.
x equals 85. Nice. So, wow. So you probably can't pick her up at all.
No.
80 pounds. So Demi, okay.
Yeah, Demi's a big girl.
And Demi's like, you know what? I really don't care.
Yeah, that's how she is. I really don't care.
Yeah. Okay, you get me. She's like, oh.
Yeah, she is. I really don't care. And that's how she looks right there with her face. She's like,
She does. All right, nailing it, Demi. I love, you know what, girl? Like, we are body positive here.
yeah, we are. Very body positive, always.
Yeah. Okay, nice job, Demi. Let's look at, lastly, Girl Dexter / Molly. We'll do one more like this, and then we'll put a pin in Z-scores for a little while.
Perfect.
Okay.
Okay. So Molly is an adult Jack Russell Terrier with a Z-score of Z equals negative 1.48. How much does Molly weigh? Recall, adult Jack Russell Terriers are normally distributed with a mean weight of 16 pounds and a standard deviation of 2.7 pounds.
Right. We were given that info back with Dexter.
Right.
Okay, so
now this is a similar problem to Demi's because we're getting the Z-score again. So we can kind of play with that same formula and lay out what we have. So we know that ours, yeah, exactly.
Sorry, I didn't mean to like steal your thunder. Give me the pieces. You can give me the pieces.
Perfect. Okay, the mean is going to be 16.
Okay.
Standard deviation is 2.7. We
Cool.
have to solve for x still because that's going to be like, what is Molly's weight? And then Z equals negative 1.48.
So is she going to weigh more or less than 16 pounds?
She's going to weigh less.
Yeah, Molly's a little baby. Okay, let's find out how much Molly weighs.
Okay, cool. So let's undo what we did for the 2.7. We'll do it to each side. So multiply.
All right, multiply by 2.7, clearing that fraction.
Clearing it.
What does this come out to?
Negative 3.996.
Okay, and then we've still got Molly's weight. Oops, why does that say equals? That should be a subtraction.
Oh, yeah.
I blame you. And then what?
My fault.
Yeah.
And then we're going to add the 16 to both sides.
And what do we get?
And that's going to give us 12.004 pounds.
I was just going to ask you that. 12.00 what? You read my mind. Because with Z-scores, that's a good thing to note. Z-scores are unitless. I mean, they're counting standard deviations.
Right.
If you want to put a unit on it, you could say standard deviation. But X values are the units of the problem. So like in this case, pounds.
Mm-hmm.
So put those units on so that you understand what the heck you're even talking about.
Yeah, exactly.
Nice. So just some nice basics on what a Z-score is, because we're going to use it a lot as we go forward.
Yes, we are.
In fact, we will revisit Luna and Dexter and Stella and Demi and Molly a little bit later, but for now, great start.
Great. Yay.
Yay. Thanks so much, Brittany.
Bye.
Bye.
You can take your